Hello everyone and welcome to Learning Minds. My name is Jyoti Nigam and I am a software engineer. This is the 11th video of Elasticsearch series and I would highly recommend you to watch my previous video before watching this video. In this video, I'll be talking about data modeling in Elasticsearch, what is parent-child relationship in Elasticsearch, and using join type in Elasticsearch. So let's talk about data modeling in Elasticsearch. So you may have heard that in a lot of distributed systems like Cassandra or MongoDB, the usual advice is to denormalize our data. And so if you're coming from a relational database background where different types of information are tied together through relations, that may seem counterintuitive. Now with Elasticsearch, you can kind of do it either way. It's up to you, whatever makes sense. So let us talk about some trade-offs of normalizing and denormalizing our data in Elasticsearch. And also how do we represent parent-child relationships in Elasticsearch. So this slide depicts the traditional relational database way of modeling the data, that is normalizing the data. So let us take example of the movie lens data set. So we imported a movie lens data set and in that we had a file ratings.csv. So in ratings.csv that file contained user ID, movie ID, rating and the timestamp field. So let's say I want to retrieve a data for a given user through Elasticsearch and I want to get the movie back. So if I'm looking for the rating, we went to the ratings dataset and we got the movie ID back. But what I want to display to the user is not the movie ID but the title, because movie ID won't make any sense to the user, whereas the movie name would. So if the movie ID is suppose 670, it won't make any sense to user. But if the user knows the movie name is Interstellar, then it would make some sense, right? So I would then do a second request that I want to get the title of the movie using the movie ID from movies.csv file. So this whole approach is the normalized approach where we are storing ratings and movie names independently, and we don't want to make a copy of the movie name and every single rating entry. So this is a much more compact way of storing information and we only need to store all the movie titles once, but it requires two hops. So you see, look up rating and look up title. So we need two hops and that is we need two queries instead of one to get back the combination of rating information and the movie title that the rating was for. Another benefit of this is that if we change or update the movie titles, we need to do it only at one place. But kind of disadvantage is that this would increase the increased number of hops will increase the traffic on your cluster. And nowadays we want optimization in terms of time and we want results to be returned very quickly and we don't want to optimize the storage space at the cost of optimizing the queries. The storage is cheap nowadays, whereas everyone wants the results back very quick and very fast. And traffic needs to be optimized. And the latency, uh, people don't want additional latency in getting the results back. You would prefer doing one transaction instead of two to get the results back to us. And we want a faster page response time and everything. So for this, we have another approach that is denormalized approach. So what is approach? In denormalized approach, we would have everything present in a single table. So in this, for rating, we have title. For every rating, we have title present of the title of the movie present. So whenever we look up rating, then we get the title back also. So what does this mean is that I need to copy those movie titles into every single rating where there is a rating for that movie. So we'll need to have the title of the movie for every rating. So we need more storage space and there is some duplication of data present. And another downside of this would be that if suppose I want to change the movie title for some reason, it would be difficult to do so because we need to look up for every single rating and then change it. But there are ways to do so. But in this format or in the case of denormalized data, the results would be very fast, traffic would be less, and there is a single query to be written to get the results back. So this was all about data modeling. Now I'll come to parent-child relationship. So it is another thing, a new thing that we can represent in a structured manner is parent-child relationships. So I'll explain you this through example. So for example, uh, that there are the movie franchise Star Wars consists of four movies: A New Hope, Empire Strikes Back, Return of the Jedi, and The Force Awakens. So I want to create this uh, parent-child relationship that Star Wars should be the franchisee and all these movies should be the films that come under this Star Wars franchisee. Means Star Wars should be the parent, franchisee should be the parent, and films should be the children in this case. So how can we do so in Elasticsearch? So I have already uploaded the commands on GitHub and I'll provide the link in the description. So let us first create a new index called series index, and in this index we are defining film to franchise field and its type is join. So what does type join allows us to do is it allows us to define parent-child relationship. And while defining join, we need to define relations. And relations in this case means that franchisee is the parent and film is the child. Means films are related to franchise. So if we execute this, we get acknowledged true. Means our mapping is created. Now I've also uploaded a file called series.json. Let me show you through GitHub. So you'll find this in, I'll provide the link to this in description and you'll find the series.json file here. So this is the file uploaded on GitHub and I provide the link in the description. So if we see this file, you will find that this format is kind of similar to the bulk API format which we studied. And here the first command is that we are creating a document of ID1 and this has a film to franchise relation and the name of this is franchise means Star Wars is the franchise. And coming to the next, we see that in this film to franchise relation, this is of film type and parent is assigned 1. So 1 is the ID of the parent. So Star Wars becomes the parent of this Star Wars episode 4. So this is how the entire file looks like. And now what we'll do is we'll import the data, we insert the data in this index, series index. So let us just insert the data in series index. So the data gets inserted and the result is created. Now we'll retrieve the data. So I'll write a search query, and in this search query, what I want is I want to search for movies or films having parent franchise. Just a second. So I've written a query in which I'm searching has parent franchise, and the parent title is Star Wars. So if we do so, we get back results. So in all these results, you can see that suppose the Star Wars episode 4 is of name film and has parent 1, and 1 we know that it is Star Wars. So we get all those movies that are having parent with ID 1, that is Star Wars. So all these are the films associated with the franchise Star Wars. Also, we can query results the other way. For example, if I want to know that this film belongs to which franchise, so we can give in the name of the film and then query and search for the franchise it is associated with. So in this query, I am searching for franchise that has child of type film, and the title of the child is The Force Awakens. So I want to get the franchise. So now if I search for this, you see I get successful result and the max score is 1, and we get the ID 1, and it is filmed to franchisee of name franchisee and title Star Wars. So this is how we do data modeling, and we establish parent-child relationships in Elasticsearch using the join type in Elasticsearch. I hope this video made some sense to you. Do comment, like, share and subscribe to Learning Minds for more such videos. Thank you everyone.